have gone wrong on Monday because I got almost everyone upset. I must have forgotten to.
You might have forgot to click the submit
Yeah, look
button.
what I have on Monday.
No one
Only
showed
two
up.
showed up. Oh, I didn't go over attendance, and the only two ones that are showing up are the ones that showed up on my previous hour. What I'm gonna do is
this positive 7 or this negative 7?
so
Or is this?
I'm a pretty is here. Shintan,
I'm so sorry, pretty.
Okay, no, that's right. Do you need help?
Carl is here, and Carl was here.
You voiced
If
So
you can start
Winston
writing, then I know
is here, and Winston was here as well. And Wapu is here, and Wapu was here. Were you here Monday, Wapu? Were you here Monday? Yes. Omar is here, and Omar was here on Monday. Arshdeep is here and was here. Steven is here and was here. That guy, I don't know. Joe John. No Joe John here. And Simranjit. Person was showing up, and then Rex was here and is here. Killer, Maxine, Jacine was here last class. Rosine was here also and is here today. Kritika is here and was here also. What's Kritika not showing? Jim Yuan is here and was here. Joy is here and was here. All right. Before I start, any questions? Any issues?
A few.
Yeah.
Yeah.
You want to bring it to the class, or you want me to help you one-on-one?
It might be a personal configuration issue more so than a conceptual.
Okay. We can for sure.
Long story short, the micro was working and now no longer works.
Oh, okay. So that sounds like a bad thing, but it's not.
4 hours into troubleshooting and yeah.
So when you write to wrong locations in memory, that could cause the flash corruption, and then you have to erase it.
Yeah, you have to do a factory reset and then reconvert back to J-Link, right?
Maybe to yeah, maybe it's even maybe
Yeah.
I won't see.
Anyways.
Oh, that's ICA3. What am I opening? Oh,
Like, let me just show everybody the answers real quick. It's not being recorded or anything.
Okay, so where should we at this point? At this point, our GPIO library should be complete. Yeah? I'd like to be very straightforward about that. Particularly the init input, init output, set, clear, toggle, read, and init alternate function. That should be completed because we've almost given you the library multiple times and going over it, so I don't think I can give any more help. So if someone doesn't have the GPIO library completed, please complete it as soon as possible. Yeah, this should be already done. We should be working on the UART library. And I've given a good chunk of the UART library as well, right?
So, is the UART library kind of like the GPIO separate? Reading it?
Well, in the sense that it's a library, yes, but it's entirely different.
Okay.
Okay. Now, we were I don't know how much of this demo we did because I got a bit ahead with the other section, but we were experimenting with a transmit message function. Was that we did some of this or not? Huh?
We were receiving, we had worked on sending before, and then looking at
Oh,
actually
just receiving, nothing else?
You open up Terra Term,
Okay.
we saw some echoes, and I believe that was the end of that
Oh,
lecture.
okay, yeah, so then I have it. Okay, so I'm going to connect to my ports once I hook up the board. And it's going to be, this one doesn't get updated, so I guess I have to open Terra Term again. Are you guys already doing some Windows Forms applications?
Yeah,
Or still with the GDI drawer? I
both.
mean, still. Everybody laughs when I bring that up, but I truly believe that it's way too much time to be invested in something more applicable. Oh,
So garbage data,
that's interesting.
and
Well, I guess
your baud rate hasn't changed since the last time you opened.
9600.
It's the same.
Okay. Let's comment this out and see if that fixes the problem. Yeah, it says the H, and then whatever I type here gets echoed. Remember, Terra Term does not enable the local echo by default, so whatever you type doesn't get replicated on the terminal unless you go and enable local echo. So the echo that you're seeing is what's coming back from the micro. Okay, so the micro is receiving a character and then it's sending back the same character. Okay? Now, we did experiment in the other class where attempting to send a message, okay? Because you were asked before to send hello world, so I don't know how that went. I got one student that showed me somewhere, or two maybe, in this class. Remember, we are all adults, so I give you things to do, to practice, just to complement what we learn in class. If you decide not to do it, I'm not gonna be after you, hey, did you do it? Right? But I'm just saying, it could show up on the exam. And then ultimately, if you try to do it and you didn't succeed, you come to me and then I'll try to help you out. Maybe look at your points, okay?
Can you still help us out?
Well, there's always a limit in terms of like how far behind you get, right? And particularly in this course. I've said it from the very beginning, this course is not 1550, it's not 1000. If you fall too far behind, there's a point where there's no recovery, because it's way too much. We built on top of previous content. So you have to make sure you don't fall behind.
Which
Okay?
one are you talking about?
Hmm?
Which one are you talking about?
Which one and what?
You said
The whole course, bro.
a two-person show you something.
Oh, well, it was Om and someone else, I think. So you were actually the other one, or no?
Show you what?
The sending a whole string to the terminal.
Oh, probably not.
I remember you showed me something. Who was it? Omar. Amar. Oh, Amar. Yeah, that's right. Yeah. Okay, and that's it. But you did show me something, I remember. That was maybe the assignment. Anyways, as a last chance, I'm gonna try to give you some help here in how to do this. Now, we're gonna try to send a message. And the key here to understand is, but before we do that, we define this three arrays here. I'm gonna put some content. I don't think I added it yet to this instance, but I do have it in the other one. Content, you know, for the pointers to strings and all that. But we know that in C, we do not have the string type, right? We have array of characters. So that is how we sort of like emulate a string in C. And the key to understand whereas the end of the string is a null character. Okay? Or the ASCII code 0. That's the end of the string. So if we're able to identify that, that is the end of the string. Now, when I declare an array of characters, I can, interestingly, initialize it like this, just like if I was initializing a string, right? And if we count the characters here, including the space, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's 13 characters. Okay? So I'm going to put a breakpoint here. I'm hearing too much noise, please, on the back there. Try to keep it all quiet. Yeah, 13. All right, so we're going to run this. And we can look at the message array. And can anybody tell me the message array, how many elements does it have?
11 including the space.
No, it's not 11. 13. It goes up to 13. It starts from 0. So it has how many? 14. But I counted the characters here, and it was 13. So what happened? What is the last character? A 0. So it's a null character. So the system, or the compiler, or whatever, automatically added the null character. That's the conclusion. Okay, even if I don't type it here, it adds it. Now, interesting enough would be to do, let's say if I add it here myself, that's how I can type a null character. You know, the backslash is for special characters. So backslash 0 could be a null character. So is it still going to add it if I do that? Let's see. These are the kind of things that you have to try. And it still adds it, right? So now it has got 2 null characters. So that's interesting. That depends on the compiler sometimes, okay? But anyways, for my other array, which is message, is of size 64. So the memory is allocated. So after I initialize it, message 2 has all the way from 0 to 63, because that's how I allocated the memory. And it is all zeros. Why is all zeros? Because of this initialization. That's how you can initialize an array to all zeros, actually. An empty array. If I don't do this, what do you think is going to happen? Let's see. See, all these kind of things you can try. When you're bored at home, you can play with this. You can try all these things. Oh, it's still 0. Interesting. Sometimes it will just show random. Yeah, interesting. Or maybe it was after that. Let me see.
There was one index with a value of 1.
Why does it want to stop there? If I put a breakpoint here, okay, let's try again. Okay, let's see. At this point, message is not yet defined. See, it doesn't want to. Why? It's almost like it's not hidden that.
You could try just doing a rebuild and seeing what happens.
Yeah. Message 2. Oh, there's a 1 here. Yeah, you saw it. Good eye. Yeah, it's not guaranteed that it's all going to be 0. That's what I wanted to show. Okay? But it's weird that it won't stop there. Oh, I think I know why. Yeah, so it's important to initialize an array properly if you want it to start all zeros. Now, one other thing that you could interestingly do here, let's put this breakpoint here, is go to all these variables that I declared here, message, and if you hover, it shows you an address, right? That is the address of the variable. In fact, if I was able to use the ampersand and save that somewhere, it will give me that number, 20023FE4 in hex. Now for message 2, which is this guy, the other array, is about in the same range, okay? 200, 2, 3, F, A4. But for this message 3, it's different. It's 800. And why is that? Well, I'll give you a bit of a hint. And this is almost like a bonus track. I'm not going to ask you this in the exam, but it complements the knowledge, right, to understand why things happen. I think if we go to this lesson 2, to the very end, I gave you this memory mapping that, of course, even at this point may still seem very confusing. But basically, this is how, remember when I said everything has an address? So your peripherals, actually, the GPIO A, GPIO B, and GPIO C, can anybody guess where they are? Well, we can actually see that. Do we have any GPIO-A here? I could actually declare it. GPI-A. And then try to go to this definition. And it's here, and it's pointing to GPIO base. And GPIO base has the port base plus 0. So the port base, what is it? It starts with 500 something, right? Where is it? Or 5,000.
500 something?
Oh, it was 5,000. Where is it?
IO4.
Here. Right? And that makes sense. I/O ports. Remember when we enable the clock, it says something like I/O. So the GPIO ports are here. And all other peripherals may be somewhere else. There's some other peripherals here as well that may have this address. The USART, for example. Are you wondering where is the USART defined? We can do the same thing, right? Let's try to look for this. Are we using USART here? Yeah, we are. USART2, let's see. Go to definition, same thing. USART2 base, go to definition, and then use the peripheral base address plus certain offset, but the peripheral base address is peripheral base, which is, it starts with 4. Okay? We go here, it looks like it's in this area. See? In general, all the peripherals are going to be here. This is just a different one. The IOs are here. Everything has an address. Okay. But going back, so that's why when you make a mistake with a pointer and you point into a wrong address, the program can crash or can corrupt the memory, because if you try to write something into this, for example, it's not a variable, it's a port. So you need to access the registers that can be written to actually write something. Otherwise, it's write protected. Okay? So that's why you cause these errors when you point to a different location memory. But going back to our thing here, let's debug this again, because we're interested in analyzing this guy. Oh, now I have this problem because I added this. All right, so message has the address 200 something or 2000, right? The message 2 the same, but this one is message 3.
Pointer.
Oh, that's a, sorry, message 3. That's interesting. Oh, now it is showing up here. Oh, message 3 is a variable, but itself is pointing to this address, right? That is the location that is holding, right? Because the pointer holds itself an address. So if I look at the message 3 itself, it's just a variable, and that is the address that is showing up there, right? And it's showing 200 still. But when I look at the address that is holding, basically the address of this, it's in the 800s. So whereas the other arrays are in the 200s. So there's a difference. If we go here, or 2000s, whatever. So we got this. For the first two arrays, and then for the other one we have this, for the pointer, right? Can anybody tell me where are the first two arrays stored in this mapping here? Where? If they are in the range of 2000 something.
It's gonna be
RAM.
a little,
And it makes total sense. All variables that you declare are stored in RAM. Okay? Which is why you don't want to declare like huge arrays because you're consuming your RAM. An array of 1000 is already consuming 1 kilobyte of RAM. And this micro thing has 32. So that is significant. That's something to consider. It's not unlimited like your computer. Computer is not limited either, but it's huge. Right? Now, where is the pointer then? What address is the pointer holding? This one, right? Not the address of the pointer itself, the address that is holding. So what is pointing to? It is in the 8000, right? So where is that? Well, yeah, well, you're right. You're right. The thing is like this expansion of this is a more detailed version of this. So you need to look at this side. So you're actually looking at this one. Oh no. Hold on.
if it's 8,000, it has to be
Yeah.
locked for.
Let's just take a look again. It's 0800.
So then that's
Yeah.
your RAM.
No, it's not RAM.
Main flash.
Flash
Main
memory.
flash memory.
Sorry, it's here.
It's a flash memory.
It's flash. Okay? Now, what is the main difference between RAM and flash?
Is one volatile, the other one's not?
Excellent. This one is volatile. You turn off the micro, gone. This one stays. Yeah, in case you didn't know, although at this point you should know, I see every semester I see students that they flashed an assignment at home, they come with the board, and then they say to me, or they just flashed it a minute ago, and I say, wait a minute, I'm gonna flash it so I can show it to you. There's no need. You just plug it in and it will run. It will run the last code that you flashed. Because it goes in here. So stays. Non-volatile. There's no need to flash and flash and flash. If you flashed already, it's gonna run the same code. Okay? Whereas this is going to disappear. So what is this telling me then? This goes into flash. Now, if it goes into flash, it's non-volatile. So that means that this cannot change. I cannot grab message 3 and assign something else later. Whereas these other ones, I can. Although, to be honest, if I want at some point do something like this, if I want to do something like this, the compiler doesn't let me. Okay? Why? Well, because this is not a string, it's an array of characters. Okay? So I will have to do something like this. Message at 0 equals like that. And then I go letter by letter. Now, how come I can do it here then? Well, because that is just the initialization of the array. So at this point, the system is grabbing the string, calculating the size, and then it's allocating the memory for the array. So that's the only time you can do that. Now for this guy here, this one is a pointer to a character, and it goes into flash. What can I conclude from that? Well, I cannot set it already. It cannot be changed, right? So goes into flash, it cannot be changed in runtime, right? Then if something cannot change in runtime, what is it?
Non-volatile.
Not volatile, but what is it in terms of the terminology for a program? It's a, who said constant? Yeah, it's a constant. Excellent. Constant. So, this is a valid way of storing a message as a constant. If it's something you want to reuse, you can by all means store it like that with a pointer.
So then what would be the difference in between volatile memory like RAM and declaring a volatile uint8?
Oh, that's totally different. Yeah, that volatile keyword refers to the fact that, well, we haven't yet discussed intervals, but it refers to the fact that the variable itself can be changed by multiple threads. So in this particular case, could be that can be changed by the software as well as the hardware. That's why all the ports are volatile, because the hardware can also change. When you press a button, you can change a bit, right? So, but that's totally different. Different, same term, but different meanings, okay? So whenever I want to define, let's say if I want to define, where would you use this? For example, if you want to declare an array with the days of the week. Since you don't have strings, you can pretty much declare an array of pointers and declare all the days of the week or the months of the year, because they're not expected to change. You're not going to change the name for Monday, right? It's Monday always, right? So that can pretty much go into a constant. And what is the benefit of that? Well, you're not using RAM, you're using Flash. So you can go as huge as you want in the message, as opposed to declaring an array of 64 just for one trace or something. See what the difference is? This uses RAM and this one doesn't. This is for stuff that's going to be updated in runtime. In fact, there's something interesting that you can see. Note by default is not shown here, but you can also see the memory. So if you go and view and you go memory 1, it's just like seeing the registers, and you can type the address. And I think I did, where did it go? I think it went away, so I'll put it again. View, memory 1. Oh, it went into here. I'm going to put it here. So you can type, see, this is the address of this pointer. Well, it's actually 235. If you type that address and you click, it takes you to the location of memory where that address is.
Hey, look, it's machine code.
Hello world. See? And that dot that you see after is probably the null character, although it shouldn't be displayed as a dot, but it's probably, I guess we can find what it is, because D, what is the ASCII code of the lowercase d? That's the last letter. See, this stuff that we're doing seems tedious, but it's the knowledge that we're getting out of this is huge. So if we look at the D, lowercase d, I have the ASCII table here, that ends up being, oops, I lost it. Where did it go? The lowercase d is, come on, where did you go? Well, you're gonna have to believe me because you're not seeing it. It happens to be 100 or 64 in hex. So this is in hex. So this is the D, right? And before that is 6C, and 6C in hex is L. Yeah, so the L before the D. So this is the end. 0A. Oh, and then after the, what was the end? Sorry, the D? The D was 64, okay. And then I have a 0A and a 0D. What are those? 0A and 0D are the line feed, the \n, and the carriage return, right? And right after that one, I have a 0. So that's the null character that the system added. See, it's all in the memory. You can read byte by byte. But this is in a different location of the memory. This is actually in the same area where your code goes. So whenever in your code, and that's how when you start going like kind of crazy and pretending to be a hacker and trying to, you know, how some people are trying to read a binary and reverse engineer the binary and try to get the source code, which is literally almost impossible. But I don't want to say impossible because there's a slight possibility.
Some
But,
people can do
but
it.
they will start looking at the binary because the binary file will look like this. So can you make sense of this? No, it's just numbers, right? But when you print the ASCII code for this, somewhere you will see, whenever you declare like a string, like a constant string, which is what we did there, it will appear here in text. And that's exactly what we found there. And there is some other text, right? I don't know that Monday, Tuesday, Wednesday, Thursday, Friday, I don't even know where it's coming from, to be honest. I didn't write anything like that.
I was like, did you declare an array at
No.
some point with the days of the week in it?
Maybe, but it says March, July, August, see? And we can search all the RAM. And of course, what you see on the right is the ASCII representation of those numbers. It's pretty cool, actually, how you can search the memory. Anyways, questions up to this point. Now, if I want to send a message, I know, as I know how to transmit that one single byte, I can just keep transmitting in a loop until I find the null character. Are we in agreement with that statement or not?
Yeah.
If I want to transmit a string, I'll just keep doing it until I find the null character. So I'm going to create a function here that passes the UART, and it passes an array of characters, or an array of uint8. Okay? And yes, you can pass an array in C. Doesn't have to be a pointer always. It can be an array. Like this. The difference with C# is like the brackets go here on the variable, not the type. Okay? So this prototype says, give me a pointer to a UART and give me an array. And I'm going to transmit it. So this function sounds a lot like one you have to code. So again, I'm kind of giving you the answer there. I'm going to do this. I'm going to initialize an index to 0. And I'm going to say, while whatever is in this array at index is different than null. Now the keyword null doesn't exist in C. See, as you can notice, this is an uppercase null. It's not like the lowercase null that does exist in C#, right? So this one is defined somewhere in this library. And the standard input-output, the null is defined here as a 0. So that is equivalent to say different than 0, okay? While this is different than 0, check for the flag so I can transmit, right? This is how we transmit a byte. And just put the byte into the transmit data register. And then increment the index. Now, of course, I could have added an extra line and increment the index, but yeah. Give me the chance of playing the fancy C programmer here, right? Because this is kind of things that you do normally in C in a very reduced, code. So this will post increment after doing this, okay? So it's a post increment. All right. So if I do this, I should be able to do this line here, which was failing, by the way. I could just say delay for 250 milliseconds and transmit the message. But I'm going to start by transmitting the first message, which is message. Okay? Not message 3. And if we look, hello world. 4 times per second. Nothing too fancy. Then if I use this message 3, I'm not going to use message 2 because message 2 is empty, right? Message 3, would it have the same effect? Yes. But someone could say, let increment the font size. Someone could say to me, oh, wait a minute, but that one is not an array, it's a pointer. It's a constant string, right? How can you then use it as an array? So what would be the answer? I'm gonna ask the question again. Let's say you coded this. Let's pretend you coded this code. And then you're talking to a friend or coworker, and then your friend or coworker who doesn't know a lot of C will tell you, hey, the function to declare here takes an array, and you pass it in a pointer. So how come is that working? It shouldn't be working. It's not an array. So what would you answer?
What? The pointer's pointing to an array. Or it's pointing to an address in which the array is being stored in the RAM.
Yeah, when we define an array, and that's the same reason why when you code in C#, the arrays are never passed by reference. You never use the ref keyword to pass an array. It's always passed by reference. Because it's a location, the array at the end of the day, the name of the array is an address in memory, the same as the name of the function. It's an address in memory. So the name of the array is actually an address. And the name of the array is a pointer that points to the first element of the array. So the compiler doesn't know really, it doesn't care if it's an array or a pointer, it treats it the same way. Okay? So that means that I can use either pointer notation or array notation here, and they should be interchangeable. Okay? Moreover, I can go here and change this to a pointer. Oh, and I'll keep the name so I don't confuse you too much. I'm going to change that now to a pointer, and then I'm going to change it here also to a pointer. All right? And I run this code with whatever message 1 or message 2, and it still works. But if you look, I'm not using pointer notation here. I'm using array because I'm using the brackets, the square brackets. Right?
Mm-hmm.
Now, if I wanted to change this to array, to pointer, I will have to remove this and say whatever is being pointed by message,
Dereference it.
dereference it, and then instead of doing this, just do message plus plus. Oh, sorry. Like that. So I'm going to dump the content, and then I'm going to increment the pointer. Okay? Now, which one of the two gets done first? I believe the dereferencing. I'm pretty sure. If it fails,
Then it's not.
then it's not. But we can look at the C operator presence. Still works. Can I confuse you a little bit more? I'm gonna go back to,
Let's do it.
to the array notation, but I'm gonna keep the pointer notation here.
Interesting.
Still works. So arrays and pointers are absolutely interchangeable. You can use pointer notation, pointer arithmetic. Instead of incrementing the index of the array, you can increment the pointer. And it will work the same way.
Because an array is just a pointer to an address in memory.
Yeah. So it doesn't matter how you do it. Now, if you want my recommendation, and you're probably going to agree with me, try to use array notation for everything because it's simpler to read. It's easier to read than pointer notation. I have to have a session of where I explain pointers in more detail, and I have some extra notes from Simon that I'm going to post on the site because we briefly covered pointers. I know that we did it just to understand the structs, right, and the registers. But when it comes to the strings and all that, pointers are important because they're used everywhere. Okay, so we're almost ready for a break. Any questions? So, the function I gave you here, see, and this is where you need to start like kind of playing, what is the word? I can't find it. It's not playing smart, playing, I can't find the word. Someone who's smart but opportunistic, how can we say? You need to read between the lines, right? I'm kind of giving you this one, right? So copy, paste, and adjust the things that you need to adjust, and then you got your library. I gave you the transmit, I gave you the receive, didn't I? Well, not directly, but indirectly, right?
We should have all of the lines / blocks of code that
Yeah,
we
you
need to
should,
create.
at this point, to be honest, if you were following and are ready to code, you should code your RX bytes and your TX bytes and your TX string. Sorry, the TX buffer is a bit different. The TX bytes are here and the RX byte. So you are able now, at this point, you should be able to send messages and receive messages. Well, the receiving part is not quite. Now, the last challenge, and this is how I ended my class yesterday, and you guys obviously are going to have an hour ahead of them now after the next session, the second hour. How could you, for example, copy the content of this pointer or this array into this array?
Use string copy.
Hmm?
Use string copy. It works for C as well.
Yeah. Well, yeah, but you, because you were here yesterday, you had time to think about it. These guys weren't here yesterday. Yeah, you did.
It works with for loop
Yeah,
as
but
well.
there's all, that is one alternative. Yeah, there's string copy in the library. There are more. There's another copy in the string library that is actually more agnostic. It doesn't. Well, the string copy is nice because the string copy is going to copy until it finds an old character, right? Whereas there's another one that you can specify the size that you want to copy. So if you want to maybe copy only a portion of the array, you can do that. And of course, if somebody's already thinking, you can always do a for loop and go byte by byte. But obviously, that's a bit I don't know. I don't want to say inefficient because behind the scenes it's the same thing. But it's just not straightforward. Okay. Now in C#, what do we have to copy arrays?
There's clone.
Okay. Okay, but that creates another instance, right?
Mm.
Yeah. So how do you copy the content of one array into an existing array? Did you guys ever cover that?
We did.
Copy two.
Yeah, well, in C# there's in the .NET framework there's a lot. Yeah, I think there's a bit converter that also does that.
And then, of
Array
course,
copy.
we were taught to just like either do a for loop
Oh,
or even you can do something with a for each loop as well.
Oh.
Just to read the,
why? Oh, maybe just to teach you the
this is what's
from
happening.
a pedagogical like point of view. Okay. Yeah, because in terms of efficiency, obviously.
It's not.
Yeah, but it's good to learn it at least to understand what's going on. Okay. Any questions? So at this point, the only difference with this, well, I need to talk about this, but I'll talk about this probably next class or when we come back from reading break. TeraTerm in particular accepts certain escape sequences that can make the TeraTerm terminal behave like a regular DOS terminal or Linux terminal in the sense that you can actually point to a specific coordinate in the terminal, you can clear the screen, you can move the cursor and do all those things. But in order to do that, you have to send certain commands. And that's why I call this one term and not UART. Because I want to stress the fact that those are commands that are for the terminal and they're not part of the UART library, although they are in the same UART library. And the other thing to note here is that these commands may not necessarily work with every terminal. Not all terminals support these escape sequences. I know that TeraTerm does, I know that PuTTY does, but the other terminal, that open source that I gave you, doesn't. Okay? And yeah, so I'm gonna give you links for this. So the only function that I haven't talked about, and this one, I don't feel like giving it to you because you should do a little bit of research. So this one, as opposed to this one, is going to transmit the same thing, an array, but up to a certain size. That's all it is, right? So you're gonna give the pointer, but instead of keeping transmitting until it finds a null character, it's gonna stop when it has transmitted this many characters. That's all it is. In fact, you could implement this one first, and then from this one, implement this one using the strlen function from the string library that actually calculates the length of the string. Yeah, so there are multiple ways to go around this, but I really want you to code this so I will release the assignment this week, so you can work on it during the break, assignment for the UARTs, okay? But I need to discuss one more thing so I can give you the assignment, and I will do that after the break. Hopefully it's as quick, 15 minutes.